Okay, we're live now. Okay, great. So looks like it's going to be a bit of a small group today, but today's going to be a presentation from remotely from Dorn and Mike Stenta, who have been working on farmos.org. And unfortunately, actually, because of some logistical issues, they're not going to be able to join us. Maybe they'll be able to catch us at the end of this, but in lieu of that, they actually recorded a presentation for us so we can kind of see it and see their tool, FarmOS, in action. And after that, hopefully we'll be able to have, with whoever comes in, a bit of a conversation about ideas of how this tool might be implemented in different ways and what can how it can be kind of extended. I think that's one thing they're looking for, ideas on how to interface it with other things like new modeling tools and ideas for how to make it usable to farmers. Before we launch in, maybe we'll do quick introductions for who's on here right now. So Greg and Dan, you want to introduce yourselves real quick?
Sure. I'm Greg, and we're at the PhotoSync project over in Dave Kramer's lab at MSU, and we have a platform for people to measure plant and soil health, basically. So sort of a big mobile-based platform. So.
Yep, yeah, and I'm Dan Travis, and I'm with Greg's group over here with PhotoSync.
Great. And you guys will hopefully be presenting sometime soon as well?
That's right.
Great. Yeah, we'll nail down a date. So. And Amanda?
Hi, I'm Amanda. I'm the executive director and co-founder of Project Drawdown, which is kind of a climate solutions think tank of sorts. We're adding up all of the benefits of various climate solutions, including all the ecological or soil carbon solutions, and kind of mapping out a path into the future of the next 30 years and seeing how fast we can achieve this point that we call drawdown, which is the point at which concentrations of greenhouse gases start to decline again, back down to safe levels.
Great.
Yeah, thanks.
Okay, so before I launch into the video that Dorn and Mike have passed along to us, I'm going to give just a quick kind of presentation of what this group is about and how it sort of came to be. So let me get a screen share working really quickly. Can you guys see that?
Let's see.
Yeah.
Great. Great. So the spark for this idea of the Open Ag Learning Series and kind of the other thing we're calling is the Open Ag Research Association came about at this State of the Soil meeting that happened just this February in California at Paisines Ranch. And there was a group of scientists and engineers and advocates, people from the nonprofit space and stuff, that were all interested in soil and regenerative agriculture and kind of how do we move that topic forward in the next few years. And one of the things that we were all talking about an awful lot there was that there's a growing need for kind of better monitoring tools and better data sets to talk about those bright spots around the country, those practitioners in agriculture who are really kind of pushing the ideas forward. And kind of as technology improves and we'll be able to monitor things more effectively, more extensively, so trying to kind of improve that technology and make it more accessible to farmers, and how to sort of, number two, interface that data that those types of producers are producing to interface it with models and make it accessible to modelers who can then take it and maybe tell us more about how what these producers are doing is impacting the environment and perhaps improving environmental services from agriculture. So this idea, the first step we realized is there's a lot of people out there doing a lot of different things. So this learning series, by what we're trying to do through it, is to try and generate a discussion and host it and kind of put these presentations up so that people can start seeing what everyone else is doing and kind of then have a discussion about what are our common barriers and how can we find ways to collaborate and things like that. So And I think Dorn in his presentation talks a little bit more about the different groups and how they have all kind of started interfacing. So that's the group, and I'm going to share this video that Dorn shared with me. So it's probably going to mute us all, but it's got a chunk in the middle we're going to have to skip where something went wrong, but it's about synthesis and common barriers. But Mike, do you want to say a few words before we jump in?
Sure, yeah. So I'm Mike Stenta, and started from the last about a year ago. Really started working on it seriously. It's been growing quick ever since, and yeah, I'm excited about the possibilities. We've got a lot of great ideas. Looking to get more people involved in the operation and the planning and the development too. And so yeah, I'm excited to demo it.
Great. So my rough plan for the presentation here is to do a little bit of background first and give some context and how sort of the positioning of PharmOS in the larger context, both within my own work but also within the Open Agricultural Learning Series, and which is some of the work that we're going to be doing throughout over the next several months. And then we'll jump into demoing the software with a couple cases, primarily using the software and demonstrating it on our farm here in New Hampshire. And then we'll go from that, and we'll try to be focusing on our two primary questions that we're focusing on here, which are looking at the barriers and how we can collaborate to help overcome them, and then envision how this tool is going to be helpful for improving regenerative agriculture. So with that, I'm going to jump in here in a second and share my screen, start the presentation. And here we go. Start screen share. So, Mike, can you see that?
Yeah, working.
Great. So, PharmOS. As we mentioned, PharmOS is an open source farm record keeping and management tool, and I'm going to give you a little bit of background here. This image I like because it just juxtaposes sort of our cellular structure of the internet there on the one side. That's a map of the current internet with soil root structure. And that's a lot of what we're talking about, is bringing sort of the silicon complexity and tools we have to bear to help manage the complexity of our soils and agricultural management. So this, from my perspective, really came about with my involvement with the soil health work and my involvement with the Cornell Soil Health Lab, and in particular the need to look at management and how important that is when we're looking at soil health. So this slide is one that illustrates that. Both of those soils we're just testing for chemistry are identical, or in fact the chemistry of the soil on the right there is actually chemically better, but from a productivity standpoint, very different. Well, what's the difference between the soil on the left, the dark, deep topsoil, and the one on the right? That's management. And so soil health requires us to not just understand the chemistry of the soil, but all of that history that went in to create that soil. That's the big difference, is that management process. And so I've been working over the last 5 years really with the New Hampshire conservation districts on a Great Bay Nutrient Management Initiative, which is looking at cleaning up soils, or creating healthy soils to clean water into the Great Bay, but also looking at the process that we require to advise management planning for soil health.
which is a very different than just put 10 ton, put 2 tons of lime down, or other sort of nutrient prescriptions. It requires a much more in-depth look at what the history is, what fits, and it's really a dialogue with farmers. And so, and that's really what soil health test is about, is not just providing, by the way, in a few weeks we'll have Bianca Mobius-Boone, one of the key architects of this test, who's now with the USDA Soil Health Division, talking more about this architecture and how that's fitting in with the national soil health initiatives. But really it's about not just the absolute values, but it's providing all of those values in a larger context, and then providing management recommendations for how to address those constraints. And so that's really important as we look at the Farm OS, and where we're trying to go with that is we're trying to gather all of the management background data and other data and put it in context so that we can make better choices which result in healthier soil and more profitable enterprises. And so, and if you look at the soil health test here, it's as important thinking about the way in which it's presented as the absolute values, because it's a roadmap. So you can see green values, and you see red values and yellow values, and that helps you make.
Sorry, I don't think your slides are changing. I still see the first slide.
Oh, this first slide, really?
Yeah, sorry. Yeah.
Oh, okay. Let's try.
Oh, there we go. There we go. Now it's working.
Okay, so which one do you see now?
Now I see the second slide.
Ah. Okay. Well, so that was the. All right.
It all made sense, but I think it's. We should probably keep going.
Okay. Fair enough. So this is the soil health test with the color-coded results, and so you can see that.
Yep.
Okay.
It's not full screen, but I can see it.
How about now?
No, it's still showing the Google slideshow or the Microsoft.
Interesting.
Maybe it's because you shared a screen, a specific screen instead of.
Yeah. Let me go back. Let me stop this, and we will.
Okay.
Full screen. And how about that?
Yeah, now I can see it.
Okay.
Great.
So Daniel probably used a similar slide to this in the intro to the series. I just want to speak a little bit to the context of Farm OS in relationship to a couple other projects. So as I mentioned, we've been working on the soil health work, which is providing essentially environmental models for actionable feedback. So it's providing feedback for management based on soil health results. Farm OS is the way in which we can collect a lot of that data and feed it back in a useful way to the farmer, but also interface with other projects like the Open Food Network, which is looking at supply chain feedback. So when those products leave the farm, and we're gathering data and feed that back into farm management. And then the FarmHack project, which is an open source research and development platform developing farm tools. So, and you'll see as we go through the Farm OS platform that we have an equipment management record keeping system, which is a logical place to fit in, again, the variable of which tools we're using and how they perform. And so we can mix our hardware with our biological feedback system. So how that crop did is also dependent on what kind of tools we're using and how we're using them. And FarmHack has also informed a lot of the tools that we have available and making available much lower cost tools that enable us to observe farms in a totally different way. So low-cost imaging chips, for example, enable us to take very high-resolution images and so FarmOS is also a way to organize some of this new data that's being collected and put it in a meaningful context, not just for the farmer, but for researchers as well. So here's some examples again of that image. At a very minute scale, you can pick out individual species at the plot level, and from that, using low-cost open source processing tools, create three-dimensional models of the crop to give you biomass volume, things like that. And also bind those together to look larger landscape patterns of color and texture, which can also indicate crop performance. So again, FarmOS is a way to also provide a platform to be able to bring in these more diverse sets of data that are becoming more readily available. And so this is just a slide to illustrate we're bringing a lot of those sensor networks, aerial imagery together, low-cost spectral analysis, water sensors. We're able to get higher bandwidth connections across the farm with low-cost bridging software, things like that that will enable us to do a much higher resolution, lower cost observation of environmental systems, so the sensed landscape. And so, but to make that meaningful, we really need to create shared environment database. And so that's where we're talking about FarmOS as the interface, the user interface for that data connected through web services and APIs to leverage all this locally collected data. So the desired state of what we're really aiming for in our future conversation is really highly accessible, low cost, with a high accuracy and high participation for this environmental sense data. Now that's from the big picture, not from the farmer's perspective. From the farmer's perspective, it's actionable data and meaningful feedback from the land management perspective. So FarmOS so essentially reflects a lot of these desires and this potential. And as Mike mentioned, he's been working on this for a little over a year. And so what we're going to demonstrate here in a little bit is taking all of these this context into account and creating a software product to represent that. So we're starting with this farm management dashboard. Some really key things to consider as we walk through this too is that we really believe that FarmOS needs to be free and open source to enable participation and adaptability and be able to be a trusted system, be able to be built upon, and that it's really important that farmers own their own data and they can control how their data is shared or not. It's very important that that's sort of the basis of it. We also recognize that the mobile-first development process is important. That in order to be truly useful for farmers, that it needs to that it needs to work well on mobile devices in the field, so we can access our records in the field or in the shop, and that we can enter data in the field or in the shop as well, rather than when at the end of the day where there's a good chance that that won't happen or won't get used. And we also believe that it's really important that there's an immediate utility from the use of the software, so that in reducing record keeping, labor, and improving decision support. So one of the things that we're focusing on in particular right now is reducing the record keeping for organic certification, and with the Food Safety Modernization Act, likewise, being able to reduce the labor for data entry and certification for those kinds of programs. But we want to have that be the basis, but in the background also create a software that provides an option to really easily share and collaborate with other projects so that we can build new functionality on that trunk. So we can get some of the benefit from the scientific perspective, from the sort of the broader landscape level, by providing a really good base or trunk from the farmer's perspective. And also from the farmer's perspective, creating a useful tool that's useful when you don't share your information, but gains, or that it becomes much more effective and much more powerful if you do share your data. So the Cornell soil health test is a great example. If you have, for example, if you're looking at your water capacity, it has a meaning as an absolute value. But if you are able to compare that with all the other farmers in your region or in the country, or similar farms like yours, you have a much better idea of how you're doing relative to other operations, and to be able to gauge the effectiveness of your management. So that's a really important aspect of this project. With that, I'm going to switch over to looking at the actual farm interface. Or Mike, would you like to do the initial intro to the farmer dashboard?
Yeah, sure. So yeah, the screen. Do you want me to share my screen?
Yeah, that'd be great.
Okay. Give me a second. All right. Can you see that?
I can see that.
Okay, so this is Dorn's farm, and it's worth noting that I'm logged into this from my computer, and while at the same time Dorn is logged into it at his computer. Multiple users can use it at the same time. It's basically a website, so it operates on all the same sort of basic rules of that. But that aside, I'll talk a little bit more about architecture later. Yeah, so essentially this is the dashboard right now that you see when you first open up FarmOS, and we've got it structured into some main tabs for the different types of things that you can manage. There's a map that you can zoom in and out on, and you can define all of your areas. Within the areas, there are direct links to records and logs that are pertinent to those areas, so you can have easy access. And this works on a phone too, so you can be out in the field and click on an area, click on animals, and see the list of animals that are in that area, for example. So then down below, there's sort of the plan. So everything is kind of based on the idea of log entry. I'll talk a little bit more about that later, but you can kind of see that it sort of organizes your plan. So it looks at all these things that you've put together and assembled as your, what needs to be done this season, and then presents it to you as a to-do list. And you can mark them as you go through. You can check off the ones that you did and click done. You reschedule them, clone them, that kind of stuff. So yeah, that's sort of the dashboard. Do you want me to go over anything else right away, or did you have other stuff to talk about?
Yeah, maybe just shrink the screen down into the mobile form so that you can just see how the bootstrap functionality is working.
Sure. I'll try to, whoops. Make it tall and thin, kind of like a phone. So yeah, on a mobile interface, the UI kind of scales automatically. This is all using other open source software that's already available. So we're leveraging software that's already been built for this purpose to design flexible and responsive web applications. So yeah, and it all works basically the same. So our goal is to always start with mobile first, so that it can be used on a small phone out in the field, or on a large screen in an office, or on a tablet, or something like that.
And I should mention, I've been using this on 3G service, and it works just fine in the field. Of course, it's faster when we're closer to buildings and we have Wi-Fi. But one of the things that that's really coming down a lot in price is actually being able to extend our Wi-Fi bubble over, instead many acres. we're now close to. We're able to actually. We were just testing this last week a a Wi-Fi antenna that's very easy to mobile mount. So we actually have 250 acres of Wi-Fi right now. So that's not an issue on our farm whatsoever. Like I said, it works fine just on 3G service as well on the mobile phone. So, Mike, how about if I jump in here and I can do a little walkthrough on our farm and sort of show how we can get a sense of the kind of operation that we're running through this mobile interface.
Sure.
Okay, I'm going to do.
Okay, so right here the video is going to malfunction a little bit, so I'm just going to jump ahead a few minutes. Hopefully Dorn will be able to fill in the holes.
Process.
Yeah. Yeah, touch on a little bit of the architecture too as an intro to that.
Great.
To give a sense of how things are kind of organized. Okay. Okay, can you see my screen?
I can.
Okay, so just to quickly touch on the basic architecture of the system, mainly my focus up until this point and continuing forward has been laying a solid groundwork for building features on top. And I'm taking some of this from background in farming myself, and also in some record-keeping applications that I've been working on outside of farming too, for like bookkeeping, double-entry bookkeeping, and that kind of stuff. So what I've tried to build here is a very fine-grained record-keeping tool. The best way to sort of simplify how it's structured is to kind of illustrate the different types of entities that are in the system. And just as an oversimplification, the two main types of things in FarmOS are assets and logs. So assets represent anything that is a real asset, like an animal is an asset, piece of equipment is an asset. Plantings are also considered assets because there's something out in the field that has value, and so on. So then, in addition to assets, we have this concept of logs. So while assets are sort of a fixed thing, logs are used to illustrate actual events that occurred, usually in relation to assets, although some can be more general. So a great way to kind of explain that is an example of an asset is an animal, and an example of a log type is movement. And that's how we are able to track the movement of all kinds of assets. So movements apply to equipment, they apply to animals, they apply to plantings. And based on the most recent movement record, you can then ascertain, the current location of the item or of the asset or animal. That it seems like, okay, well, that's a lot, there's a lot of detail there, but that's a good thing. That allows us to then see a list of all of the movements that have taken place for every given asset. So each one of these is a log, a movement log. Other types of logs include activities. So you can record a specific activity of an animal or a piece of equipment or planting. Observations are another type. So observations would be like a passive log entry where you're out in the field and you notice something and you want to record it and take a photo. I had a falcon attack my chickens the other day, and after that happened, I took a picture of the chicken that got wounded and sort of then kept track of the killing process and activity like that. So the same thing can apply to any type of asset. And that's the idea. There are other entity types in the system. Saying that it's just assets and logs is a bit of an oversimplification, but that kind of gets to the core of FarmOS. We're also leveraging the taxonomy module of Drupal very heavily. That's for categorization and basically just large vocabularies, hierarchical vocabularies of things. So an example of that would be animal types. So if I go back to the animals list and see the types, these are all essentially taxonomy terms that are used to describe animals. So you can tag an animal and say that it is a brown Swiss cow. You can also tag them into different groups. So these are the ones that Dorn is using, but they're very flexible and they can be arranged hierarchically so that you have child and parent relationships on all of those. The same thing applies to crops when you're talking about plantings, and we'll eventually be adding like equipment type and that kind of thing. So those are other vocabularies that we'll be using. So then, yeah, to talk about import and export, what Dorn was saying, essentially, you know, we're building this whole system on top of existing open source solutions. There is definitely some custom code that I've been building to sort of bring it all together. The farm assets and the log entity types are custom types that I've created and added to this. But a lot of the functionality just comes from the Drupal ecosystem and community that's already building a lot of different sort of applications. The taxonomy module is one example that comes with Drupal. But in terms of imports and exports, we're heavily using a module called views. And views is what allows us to easily build lists of all kinds of things. So we can build lists of assets, we can build lists of logs, we can build lists of taxonomy terms. That's how this entire interface is being generated, essentially. And the views module allows us to easily build that without writing a line of code, which is really nice and allows other people to start joining in and tweaking these so that they can come in and add a column if they want something else to be displayed in here. So to get back to the export, views can also be used, it can be used to print this stuff as a table within the interface here, or it can be used to export to a CSV file or an XML file. So there's lots of options for us to build ways of exporting this data.
So, and Mike, I just want to interject here. That's when we, this year, we used a special view that was created for our organic certification. So they had a certain form that they wanted to see the field records in, and it was a fairly easy process to format the output from each field to look at the history of what was planted, where animals were, and where the plan was for this coming year, and to be able to present that for the certifier. It was, and that was a much easier process for us even this year than in years past to be able to hand that off to the organic certification certifiers.
Yeah, and that view that we cobbled together, we did in what, like 5 or 10 minutes? And
yeah, exactly. So it's a good illustration of the power of that process.
Yeah, and then that we were able to incorporate into FarmOS itself. So we built that specifically within Dorn's site or his needs, and then we're able to export that and merge it into the trunk, as you called it, Dorn,
right,
project, so that other people can leverage it too. And that's a lot of how the Drupal community and what development in general, distributed development, works. So there's a lot of room for community growth as adoption increases and people start using this. I've been very surprised to find that a lot of farmers know Drupal, or maybe I'm just meeting the right people.
Well, I think the other thing that I think is worth touching on, Mike, is just that the architecture and how easy it is to spin up new farms and to host additional farms or have new hosting services, so that again, this is something that doesn't require a lot of specialized infrastructure for deployment.
Yeah, absolutely. So setting this up is like setting up any website. It's a Drupal-based system. So you download it, install it on a web server, install the database, and then you're up and running and you can access it from anywhere. Likewise, if you're not comfortable doing that, you can have it hosted by someone else who is more comfortable, like a web developer or a service like Farmyard, or kind of hosting sites like this.
So It would be worth just showing that, again, because this is a website built on Drupal that has all the permissions built in, it's been very robustly or well-tested permissions process, that we're able to share this with other folks and limit and sort of set up different roles. So, for example, certifiers or certified crop advisors, extension personnel, etc., all that have different ways to access different parts of this data. So or you might log into Wolfsneck, for example, and just show that we can very quickly go from one farm to another where we have we're able to monitor how they're setting up their site and what's going on currently on their farm.
Mm-hmm. Yeah. Yeah. So the roles and permission system of Drupal is very strong. It gives you very fine-grained permission controls over every individual piece and feature. And it's not hard to extend that too if it doesn't do what you already need with a little bit of programming. So right now we have a farm manager role, which gives access to all of the farm management stuff, but we could also easily add more limited roles and specific sort of things that that we'll need for more fine-grained permissions.
So I guess one other thing, we're getting close to time here, but I do want to touch base on the other integration with the sensor networks that I mentioned earlier, as they're becoming more and more available with low-cost, soil temperature, moisture, greenhouse temperature, all that kind of alert system to allow for a better understanding of sort of feedbacks from the landscape. Do you want to just touch a little bit on that? I mean, we will be able to, I guess one of there's some overlapping projects that will come up in this Open Agriculture Learning series, but that we will be able to have visual displays of some of that data and alerts on that central dashboard, probably in the fairly near future through the that Open Layers interface. Do you want to just talk a little bit about that?
Sure. Yeah, this is something roadmap, and it will not be hard to implement. It's really right now we're kind of in the discussion phase, and I'm talking with like RJ Steiner about the best way to implement it. We want to make sure we set it up right to start. But yeah, the screen that I'm sharing right now is the specific task for a farm sensor API that we're going to build in FarmOS. So this is sort of where our discussion is taking place, and that's all. It's also worth pointing out that we've got a pretty organized method of discussing new features and ideas and questions within the Drupal.org project management stuff. We may be moving that at some point, but for now that's working really well. So if you want to take part, there's places to do that. But yeah, the ultimate plan with the sensor API is that you'll be able to tie them to specific areas and assets in general. So that, for example, if you're on a map, you could zoom into an area, click on it, and then in this pop-up box, it would show you some summary of sensors within that area.
Right. And we'd also talked about changing some of the color codes, so whole areas could actually be displaying at different colors based on sort of alert levels.
Yeah.
Yep. And so forth. So one of the questions that we were addressing here are what are some of the barriers that we're facing right now and how this group could help. And I really think that one of the main things is this really becomes powerful through collaboration. It's really that's what it's meant to do, is provide a trunk that will allow for data to flow through and out of it. But then also equally important is to be able to bring that data back after it's been processed through decision support processes, either, say, for example, the Cornell soil health test, or in the case of, say, Comet Farm, as we've talked about before, or other environmental models that will have some form of feedback that's useful to the farmer for their management. So it's really, I think the barriers are really in developing standards and agreements to allow for the data to flow in and out of this system, and to find additional users and feedback on making this system more accessible and easier to use for farmers. Do you want to add to that, Mike?
No, I think that sums it up nicely. Yeah, I think yes, that's great.
I mean, I think from our project and its role in regenerative agriculture, I think everything that we're working on here has to do with increasing the level of feedback and frequency of feedback and quality of data that's coming back to the farmer who's responsible for making management decisions. So I think it's really a crucial piece to identifying for creating a better understanding of our environment, which is, I think, one of the keys to regenerative agriculture. And as we've talked about at the State of the Soil event, there's a real need for collecting better data to enable better understanding and better modeling of the environment, of the regenerative agricultural systems that are already out there and functioning, but making those systems transparent to a wider audience, and constantly improving the quality of data coming back to the farmer. So, but with that, we're pretty much at our time limit. And I'd just like to thank everybody for bearing with us for a pre-recorded presentation, and we really look forward to joining you all in the weeks to come. And please be in touch. I'll be available later today and happy to answer questions and responses. We're going to try and get a response or question page up on the Open Agriculture Learning Series website. So I really look forward to talking with all of you and continuing this exciting dialogue.
Yep, same here.
Great.
Great. So thanks, folks, for kind of bearing with that there. It was pre-recorded, as Dorn was saying, kind of a last-minute logistics change for him on a flight. So, but at least gave us a good chance to see what FarmOS looks like and hopefully think about kind of how it might interface with other tools and stuff. So looks like we may have lost Amanda, kind of a slim group today. I know a lot of folks are at a meeting with the Soil Renaissance Project, so perhaps that's why we're a little slim. But Greg and Dan, just wondering, you guys thinking about your tools with PhotoSync and ideas for Carbon Sync, and what you think about how FarmOS might kind of work with that. Just some responses. Oh, I think you guys are muted still.
Sorry, turn on the video, forgot the audio.
Okay.
Yeah, it was more well developed than I sort of expected. I guess I didn't have a lot of expectations because I hadn't heard much about it before this. But it looks pretty good. I think from PhotoSync sort of perspective, this is just sort of one more place to throw your data in, basically. We're fairly agnostic as to where the data goes, and we know that for it to be useful, it has to be combined with lots more information. And so, sort of getting into the nitty-gritty of how, basically API communications to make sure that you can pull data from us and vice versa as needed is pretty much it. Unless, it depends, I guess, on the level at which FarmOS sort of wants control over the components within its system. Those are the sorts of things that we have to figure out. Like we're doing that with Open Data Kit right now, So there's a lot of these systems, and they all, it's like, how do you get data from one place to another, and how do people talk to each other and all that sort of stuff. But really, for the most part, it's just, as long as everybody builds like open APIs, it becomes pretty easy. The only problem with that is then the user, the farmer, or whoever is having to have an experience through lots of platforms instead of through a single platform. So, there's like pluses and minuses to that. But I think it's a great system. I mean, someone needs to build it because there's a lot of these farm management systems already, but they're all proprietary. And I mean, to my knowledge, like an open source version does not exist. So.
Yeah, I think the closest thing I can think of right now is Ag Squared, which is something like $300 a year, and then if you want a kind of premium version, it's $700.
Mm-hmm.
So yeah, you're right. I think an open source version needs to happen. I mean, based on your guys' experience with launching PhotoSync and kind of creating the interface there, do you have any particular thoughts on how to make it the most kind of user accessible, user friendly, things like that?
Well, we certainly had a lot of feedback from users. I don't know there's a lot of design lessons which are generally applicable to all design. I don't know how much more applicable it would be to this as compared to anything else, but I mean, in general, it's always surprising what the users will say, I guess, has been our experience so far.
Yeah,
or at least surprising to the developers.
The roadblocks that people run into on the mobile apps are not what the people on the development end are expecting.
Right. It's things like, I don't know, I mean, for example, when people are collecting large quantities of data, they don't want to have to enter in values on their phone. Using the phone's keyboard is like death. Good luck getting a farmer to use the phone's keyboard. It's just, they'll do it once, and then the second time they'll be so frustrated they'll put it in their pocket and they won't ever do it again. So things that you think as a developer are relatively simple, your users, a lot of them might not. Connection issues is another one. Like we were running with Bluetooth, and every stupid device is different. Sometimes you have to reset your Bluetooth, and there's these things that, like, if you've had a phone for a while, you can kind of figure it out and troubleshoot it. But most users just won't. Once they hit one of those little, what you would consider as a developer, a little stumbling block, like, you recognize that the world isn't perfect, but the user will just drop it and they won't pick it back up again. So I think, that's why commercial services exist that charge money, because to get to that level of user experience that 90% of the market will use, or not even 50% of the market will use, just takes an immense amount of user feedback and tweaking, and feels like nonsense, but is actually quite important. So that's the biggest feedback we have so far. Yeah. So I'd love, since they're an open source project too, especially if they have farmers, people who are actually farmers, but can also give like feedback or even like code directly, which is unlikely to have like farmer user. Dorn is probably like the only guy in the country who's like farmer / coder / I don't know.
And then Mike there too, who's presenting me. So.
I guess so, very few. But if you had those, then the user can also be, they can understand their own experience and then just code their own fixes in real time. That would be amazing, but pretty rare. Usually you have to have an intermediate in there.
So absent that kind of, which would be a great, and absent, commercial revenue, what do you guys think is the kind of thing that can help push development along the best? Grants, or kind of being able to house the project within an institution, stuff like that?
I don't know.
Those two tend to go hand in hand, don't they?
Yeah.
Yeah, I don't know. That's the, from the development standpoint, you can speak to this more than me. The big chunks of money that you can get with a grant that can allow you to just like focus is useful, but then it can also make you lose focus, I think, on what the primary goals were. I think it could go either way.
Yeah, you can end up writing a grant for the thing you can get money for, which is not the thing you actually want to do. And then you end up developing features for a population which really isn't your population of focus. And then, that does help you to a certain extent, but it's not, like Dan said, it can get you a little off track too. I guess from my perspective, and I've heard this argument from people who have considered making like nonprofits and stuff too, I think if you're working with farmers, farmers are expected to make. Farmers are little businesses. They're expecting to make money, and they're going to understand that. Just like a co-op, right? Agway in New York, we have Agway co-ops. The farmers know that Agways need to cover their costs, right? So a farmer understands that, yeah, I'm a member of Agway Co-op, but I still have to buy the seed from Agway. They understand that they still have to pay for the service because Agway has costs. And Farm OS will have costs. Maybe they can defer their development costs, and grants, I think, are a good way to do that. But they're going to have continual costs unless every farmer is going to set up their own server, which is exceedingly unlikely. So I think they may have to think creatively about how they can be financially sustainable. I'm sure they're thinking about this. Like, I'm just saying stuff I'm sure everyone already knows. But
yeah, and I wish they were here to respond to that.
yeah, I'm sure. The key is, I think, I don't know. I don't know this. I'm just saying this is what I think is, if they can create revenue streams in which the members, one, they can maintain sort of an open source platform, and two, their members feel like those revenue streams sort of are legitimate and make sense and aren't scalping them, and don't change the nature of the project being open source, then they're golden, right? And that's kind of a tall order, but I don't think it's impossible. And then, because they're going to have to develop more stuff, and it costs money, takes time, I guess, ultimately. Do they have any? I mean, have people talked about, like, what's the model, like the sustainable model for farm roles? Or what's that?
Yeah, I mean, that's a kind of question that Dorn and Mike would be better able to answer. So, but yeah, but they'll definitely be available, and I know they're eager to talk with people. And since you guys have had some similar experience, yeah, that would be a great thing to chat about. So yeah, I think off the broadcast I can send you their information and stuff. So
yeah, I'm super. I mean, one thing that we found, just like a quick idea, we've realized now as we start to spin this off is, if your project is sort of like attractive from the grant perspective, you can essentially leave all the development costs, which is your big overhead component, in the university. If the university sort of like, if it's a win-win for the university, you're able to get a bunch of grants in the university, you've got somebody who wants to drive that, let them drive it. It keeps all of your development costs in the university, and then the spin-off can be the one that manages the potential revenue streams. So a normal company has this massive overhead of development costs, plus at the beginning very like trickle-in revenue streams, so they have to go out and get a bunch of money to cover the difference, right? Until the revenue streams build up enough where they cover themselves. But the magic kind of what we've done a little bit, and possibly what they can do, is keep the development costs in the university. If it's all open source, there's no IP, there's no transfer to this new company, right? And then just start with the revenue streams in the new company. You have no overhead, so your ability to get cash positive quickly is much, much better than somebody with all of the overhead. So I think there is kind of like a component of magicalness. You can kind of get there if you structure it right. And being open source is a huge benefit to that, because there's no restrictions, there's no IP. The university can't complain about it. You just do it.
yeah, I think they may be taking that approach, kind of getting UNH to adapt it as their primary kind of management software for all their ag experiments and all of their kind of properties that they have. So that might be kind of that sweet spot that you're talking about. So
Yeah.
getting them to help with the development costs while the idea kind of takes on a life of its own.
Yeah. Very cool. Well, we should have like a get together. You probably already are going to do this, but because there's a bunch of groups. There's guys making drones. I mean, there's so many different people developing components that could plug into this to get everybody into one place and understand how to connect to this, or how we can make small modifications so that you can use our tool or somebody else's tool. Would be very helpful for us. So.
Yeah, exactly. That's the idea, I think, behind all this. So glad people are coming into it. So.
Cool. Good knowledge. Yeah.
Great. Well, thanks. Thanks to everyone who's viewed it, and like I said, we'll put Dorn's information and some links to FarmOS along on the website. So if you have questions or interests and stuff like that, you can get a hold of him. So, with that, see you guys hopefully all next week.
See?